So a few people have come up to me so far saying that they were measuring current and everything was going well. And then all of a sudden, whenever they try to measure current, they get nothing but zero on their multimeter here. And that probably means that you've blown a fuse. Not a big deal. They're meant to be blown and replaced. So we're going to talk today about what happens if you blow a fuse, how to tell if you have a blown fuse, and a quick workaround if you need to really make a measurement. As long as you're careful, we can kind of bypass that system. First though, let's talk about why you might blow a fuse. Remember when you're making a current measurement with this multimeter, what you're effectively doing is you're placing a small resistance between these leads here and measuring the voltage drop across that. You want a small resistance because you don't want it to affect the current that you're trying to measure. However, if you put that small resistance across a voltage source, you effectively have V over R to be very large, i.e. the current is very large. In order to not burn the internal guts of this multimeter, the current passes through a fuse, and if too much current goes through it, that fuse will burn. So ideally, a fuse is just a wire. When it's working properly, it's a wire. When it's blown, it's like an open circuit. And it's calibrated such that when too much current passes through it, it will blow or burn and will no longer conduct current. Better to replace the fuse than the multimeter. So what we'll do is we'll pop this thing open, have a look at the fuse and see whether or not it's blown, see how to replace it, and see how we can kind of MacGyver a quick fix if we need to. Okay, so let's go to the workbench and pop it open. Okay, so let's test this fuse first of all to see whether or not we think it's blown. So what I've done here is I've made a very, very simple test circuit. In fact, all I have here is a 5-volt source, and that's going to go to a resistor. It looks like a 2 kilo ohm resistor, and that goes to an LED, this blue LED here, and that's it, and that should turn on. So when I'm making a current measurement, I want to break the circuit. So I want to measure the current through here. Easiest place to do is break it there. So what I've actually done on the board here is put my 2K resistor here, and then nothing, and then I put my LED to ground. So what I'm going to do is put my multimeter across this point, and the current's going to flow through these wires, as if I had just placed a wire here. So in order to make sure that I've wired up everything right, I'll just actually put a wire here. We get the LED turning on. I can measure things like the voltage across the system, which is about 4.97 volts, if you can see that, just about 5 volts. And I can do things like measure the current through this 2K resistor. So my current, I think, is roughly 1/2000th of that, which is about 1.2 milliamps. Let's try to measure the current now. So I'll disconnect my circuit, and I'm going to measure it across this point. And let's go to do that, and our thing does not turn on. With the wire, our LED turns on. With this multimeter in current mode, and I have the right leads in, it does not turn on. I just get 0. So I probably blew a fuse. So let's open it up and have a look inside. So I'm going to get a small Phillips screwdriver and just pop it open. Okay, in order to pop this open, I have to take this plastic case off. And now I have these 3 points that I got to unscrew. So I see I have the battery case here. That's all going to come off. Sometimes it's a bit sticky, so what I'll do is I'll get a secondary screwdriver, flathead, and I can just kind of pry it open gently and have a look inside. So this is what our multimeter looks like. Here's the fuse for the 250, and I have F2, which is for my 10 amp setting here. We can see the current actually flows through here. And there's, it looks like my shunt resistor for my large amperage. Interesting. But we see here that current actually has to flow through this fuse in current mode. And if it cannot, if the connection is cut, it's not going to work. So we'll take that flathead screwdriver and just gently pry off this fuse. And have a look. Okay, so there's the fuse right here. It says 250 milliamps on it. And if it's a wire, I should be able to connect the circuit here. So that's no good. It does not work. This fuse is blown. I also happen to have on me a good fuse that should work, and I'll put that in that circuit here. And what do you know? It turns on. So this fuse is good, this fuse is bad. I'll mark it just so I know which fuse is which. And I should be able to put this back in now and actually make a measurement. So let's just speed through that process. Okay, fuse is back in. Now let's test it to see whether or not it works now. I'll put it to our 20 milliamp setting and have a look. Beautiful. Light turns on, 1.15 milliamps. And we'll round it up to 1.2. And we are good to go. So this is good. This works. We can now make current measurements again. Now, what happens though, you might be saying, if I don't have a fuse and I'm in a stressful situation and I need to make a measurement? We can be very careful and we can bypass the fuse system as long as we know what we're doing. So let's do that. There's a bit of a hack we can use in a pinch to replace, rather not replace, but override a fuse. We don't want to do this unless we're sure we're not going to be drawing too much current, and this is a temporary measure only. But let's have a look at that. Okay, so we're going to pop out our nice good fuse. Put it safely aside. And here's our blown fuse. Now, what we can do is we can replace this whole thing. We can basically jump these 2 points here if we're careful. Remember, there's nothing protecting your circuit now if you accidentally put too much current through it, so you got to be careful. But what I'll do is I'll get a bit of aluminum foil, or aluminium foil, as they say over the pond, and use this to short over the fuse. Aluminum is a decent conductor, as we can see here. I can actually make a circuit, a very good low resistance circuit out of this. So what I'm going to do is I'm going to make a small square of aluminum foil. I'm going to wrap up the fuse in this aluminum foil. So what I'll do is I'm going to kind of gently put this back in here and pop the lid back on. And let's give it a test. Let's see, I'm interested to see what we actually measure here. And we get our current measurement. Notice that it's slightly off. It's off by the last significant figure, which normally we take with a grain of salt anyway. But I think what happened here is that this fuse actually has a different resistance now that it's being jumped by this low resistance aluminum. And we've actually systematically offset this calibrated current measurement, which is completely possible. Either way, that's something to note. So we're off by less than 1%, so that's not a huge loss. And the next step for me, if I did not have this fuse here, is to run down to the electronics shop and buy an extra fuse, replace it at my earliest convenience. But in a pinch, we can use this now in current measurement mode. Okay, so we've replaced our fuse. It now works. We can measure current again, and we're set to go. Remember, if you do use the aluminum foil hack, be careful, because there's nothing protecting the circuit. In this case, we are careful because we have a voltage source which is current limited. The source I was using here and then we're using in the labs have a 250 milliamp maximum current. So, in summary, when you're measuring current, make sure you do it in series. Make your multimeter part of your circuit. If you measure in parallel, you can draw a lot of current through this thing. You won't get the right answer, and you might blow a fuse. If you blow a fuse, do not panic. We can fix it temporarily with some foil, as long as we're careful, and permanently by buying the proper fuse. I hope this helps.